I don't really know who did this, but to make some audio for it, I thought I might as well read some of it and explain some of it for people. On the right hand side, you have a Hertzsprung-Russell diagram. Now notice I forgot to put white dwarfs in there. But you have really hot stars at the top, really bright, blue, cooling, shrinking, and dying, and becoming gaseous, becoming liquid, and becoming solid. Of course, you can include supercritical matter in these areas right here, because supercritical matter is very important as well. But essentially, it has the star cooling, shrinking, dying, combining all the elements into molecules and forming what are called the planets. Meaning, all a planet is just an old star. They were never mutually exclusive. Stellar metamorphosis is a theory for star evolution. It explains what happens as a star cools and combines its elements into molecular compounds. It holds that stellar evolution, being planet formation itself, is dominated by chemical processes at higher energies, not nuclear processes, as observed in active galaxies and radio jets. It holds that the root assumption of astrophysics, namely that stars and planets are mutually exclusive, is incorrect. Stellar metamorphosis holds that stars and planets are the same objects, only in different stages of evolution. Therefore, planet formation is stellar evolution, as they are the exact same process. And here, they had actually even made a contents out of it. That's really, really cool. Right here I have the problem solved. It is proposed by Mr. Zachikowski, I think that's how you pronounce it, that in stellar metamorphosis, a star is a young astron, and a planet is an old astron. This meaning both are astrons. This renders obsolete the need to define objects mutually exclusive of each other, which was rooted in the philosophy of appearance of astrons taking precedence. It also renders obsolete the need to define exoplanet, planet as mutually exclusive of star, as they are the same objects, only in different stages of evolution. And that's a really big difference between this theory and the star water theory and electric universe and all of establishment physics, is that they think planets and stars are mutually exclusive. They're not. They're the same thing. One's just hotter, brighter, more violent than the other. Brown dwarf classification. Here's another problem solved. Stellar metamorphosis states that the problem with mainstream astrophysical science with defining brown dwarfs mutually exclusive of planets is non-existent, as brown dwarfs themselves are stars in intermediate stages of evolution and will eventually solidify from their gaseous state into solid structure, thus becoming a planet. That's very easy to understand. The formation of life. It is stated that as stars evolve, life evolves on them. As they die, the life dies as well. Directly from his writings. This is interesting. You have to find where I put this. Oh, right there, okay. The chemical reactions necessary for the formation of life, from the formation of molecules from ionized plasma to polymerization of the molecules, meaning making chains of molecules, to prokaryotes to eukaryotes, and then to multicellular life, to sea plants, then to animals and land plants, all result in a series of stages of a single star's evolution. End quote. It also states that stars obey the mass-energy equivalence and the conservation of mass, in which stars that radiate and lose their mass to solar wind and flaring will lose their mass. I overview this in the mass loss principle, as they are not thermodynamically closed systems. A lot of mathematicians, they like to make things perfect math models where everything obeys the math formula. But the more correct the math is, the less it has to do with reality. So their math is really correct. I mean, meaning that there's a lot wrong with it, to say the least. This means stars that are radiating the most have active solar wind and are losing mass the fastest, and the older stars, which Jeffrey Walensky calls black dwarfs, do not lose any appreciable mass because they are not radiating as much nor have solar wind. If you see any solar wind coming out of Mercury or Venus or Mars, you let me know. At least in the rate at which the sun is producing it. As well, the heat capacity of the Astron's atmosphere changes as it evolves, leading to increased and decreased rates of both chemical synthesis and energy loss to interstellar space from photoevaporation and internal convective radiative heat loss. So, heat capacity meaning how well it can trap the heat. In this theory, you have stars starting out as really big, hot, and bright, and a lot of the heat being lost externally into interstellar space. But as the star cools and dies, the heat moves towards the central regions of the star, and as the molecules are formed, they trap the heat for longer periods of time. So the star's life can expand exponentially, and it remains hot for very, very, very long periods of time. Here I have the formation of water oceans. This is an opposed to star water theory. It is also referenced that in order for water oceans to be formed, many levels of exothermic reactions are required, including plasma recombination, condensation, and chemical synthesis reactions, including double replacement and single replacement reactions, i.e. the mixing of acids and bases. This means the hypothesis of comets seeding water oceans is unnecessary. The formation of rocks and minerals. The theory of stellar metamorphosis covers all matter in gaseous and plasmatic phases, which is not covered by the rock cycle. This new theory assumes that before rocks and minerals were sedimentary, igneous, and metamorphic rock, the material consisted of much simpler compounds such as molecular radicals, both anions and cations, which is positive and negative particles, and was also fully ionized at one point, meaning a complete plasma. This meaning all the rocks and minerals on Earth or at one time were completely different phases of matter earlier in the Earth's evolution, when it was a much hotter, bigger, younger star. That's very, very important to understand. We have observations of stars inside of all phases of matter, not just plasma and gas matter, but liquid, solid material as well. And they wrote here, crank theory, stellar metamorphosis, claiming the direction of phase transitioning. Well, this is important. I wouldn't really look at that word crank. That doesn't mean anything. It doesn't have any significance. We're talking about physics here, not social constructs. But anyways, you have stellar metamorphosis going down, and enthalpy of the system is the amount of heat inside the system. So when you have your star born, the enthalpy of the system increases considerably because it takes the solid, liquid, and gaseous material in interstellar space and it ionizes all of it into a hot young star. And then once it makes the big hot ball, then the plasma recombination takes over and it starts cooling, shrinking, becoming gaseous, solid, and liquid material. And there are feedback loops when it does this in the interior regions of the star. So as the star evolves, it goes down, and as the star is born, it goes up. Pretty basic. The crank theory, I would ignore crank, that doesn't mean anything, also states that physical thermodynamic phase transitions are much more important in the determination of stellar structure and evolution than our mathematical models. It states that a young star will become a gaseous star, or a gas giant further along its evolution as it loses mass and the plasma recombines and neutralizes. This means the majority of the reactions are exothermic, meaning heat releasing. This is a very important word to realize. You have endothermic, which is heat absorbing, and exothermic, which is heat releasing. A short description of the theory holds that gravitation is secondary to magnetic and electric interactions within fluids that are plasma, gas, liquids, supercritical fluids, and solids. Phase transitions are stressed, as well as the pneumatic and hydraulic properties of matter as stars cool and shrink. Stellar birthing versus stellar metamorphosis. It is referenced that to birth a star, the majority of the thermodynamic phase transitions be comprised of endothermic or heat-absorbing reactions. We went over that earlier, heat-absorbing. These reactions include ionization, melting, vaporization, and sublimation. The metamorphosis evolution of it will be comprised of exothermic or heat-releasing reactions. These are mostly comprised of recombination, solidification, which is crystallization of crystals and amorphous material, condensation, and deposition. This means that a star is not internally powered, but is a result of a much larger, earlier event, which is having its energy dissipated via star formation. This earlier event is considered as galactic nucleosynthesis, which has the required velocities of material to fuse matter on the nuclear level, thus also obsoleting the fusion model of stars. Alright, I think that's good enough for now. I'll go ahead and read the next part in another video. Today is February 17th, 2016.